Okay, I need you to hear this because I am so excited. I did not stop using frontier AI models. I stopped paying the smartest, most expensive intelligence to spend its day doing intern work. That change reorganized my business. On the workload I will show you, it projects beyond $12,000 in first-year savings while keeping premium intelligence exactly where it matters. Using one giant model sounds sophisticated. It is not. It is like hiring the world's best strategist, then paying premium consulting rates to copy invoice numbers all day. Why are we doing that? Every tiny request looks cheap until volume arrives. Multiply the prompts, agent steps, retries, and months, and suddenly your AI workflow has a luxury car payment. So I changed the architecture. I built what I call my AI org chart, and it is simple. At the top sits a frontier model. It understands the goal, creates the plan, identifies difficult reasoning, reviews exceptions, and assembles the final answer. It is the strategist, orchestrator, advisor, and extremely demanding quality control manager. Under it sit local models running on hardware I control. They are focused operators handling repetitive, clearly defined work at volume. Between them sits validation, schemas, checks, acceptance rules, and an escalation path for exceptions. That is the shift. The frontier model stops being the entire company and becomes its manager. Now let me show you my setup, because this is not a cute diagram I invented yesterday for content. I run Qwen 3.6 35B, A3B locally across two Ryzen AI Max Plus 395 machines. In our workflow, it averages 44 tokens per second, fast enough for serious coding. This is an open-weight mixture of experts model with 35 billion total parameters, but only around 3 billion activate per token. Its official model card emphasizes repository reasoning and agentic coding. I configured it inside Claude Code. Then I made Fable 5 the lead agent. Fable has a standing instruction: always spawn local Qwen subagents to execute tasks. Premium tokens are not for every implementation step. Fable must orchestrate, advise, and validate. It reads the project, creates a plan, then turns that plan into task contracts. By contract, I mean every subagent receives a precise objective, exact inputs and file constraints, allowed tools, and an expected deliverable. The contract also contains acceptance tests and clear escalation conditions. The Qwen subagent executes locally. Fable checks the evidence against that contract, approves strong work, requests corrections, follow-up assignments, or handles exceptional reasoning itself. That detail is everything. I am not telling a cheaper model, go build my project, good luck. The frontier model manages the work, inspects the evidence, and refuses to accept outputs that miss the contract. This system made our projects execute faster and reduced token costs by as much as 90% on many projects, while maintaining the same output standard we had from frontier-only workflows. That is the win, and Fable 5 is not sacred. Replace it with GPT 5.6 Soul and keep the same architecture. The logo matters less than the instruction to decompose, assign contract-based work, advise, and validate carefully. The orchestrator needs judgment. The workers need bounded jobs. Software needs deterministic checks. Humans own risky decisions. When those roles are clear, expensive reasoning happens at decision points instead of inside every repetitive digital keystroke. Local tools such as llama.cp and Ollama can serve open models, while Quantization shrinks them so they use less memory and often run faster. Quantization is basically compression for model weights, with an important trade-off. You exchange some precision for a smaller model. That can reduce quality, so do not hear compression and assume magic. It is a dial. You test the dial against your work before trusting it production. Here is what made me realize this was not merely my theory. Stanford researchers tested frontier and local models together on long financial, medical, and scientific documents using the hierarchy I am describing. The frontier model broke each problem into small jobs. Local models processed those jobs across documents. Then the frontier model aggregated filtered results. Their 8 billion parameter local home system recovered 97.9% of remote-only performance. It did that at 18% of the cloud cost. 18%? Their naive version was cheaper, but quality dropped because smaller models struggled with multi-step instructions and very long context. Architecture changed the outcome. The fix was not simply buying a bigger model. The fix was giving the smaller model a smaller job. Decomposition makes local intelligence dramatically more reliable and useful. A frontier model can examine a messy objective and say, extract these fields, compare these sections, flag contradictions, then summarize only relevant evidence. The local worker does not need the strategy, only one clean assignment. Consider customer emails. A local model labels each message and returns a structure. Software checks it. Anything malformed, uncertain, unusual, or sensitive moves upward. The frontier advisor focuses on exceptions instead of reading everything. For invoices, extract vendor, date, amount, and purchase order number. Validate every field and escalate conflicts. For content, generate headline options locally, then let the frontier model choose the strongest direction and polish the final winner. For internal documents, keep raw files local. Let local models search, chunk, tag, and compress relevant evidence. Send filtered findings upward instead of pouring your entire digital filing cabinet into the cloud repeatedly. Privacy and cost begin helping each other. Less raw context leaves the machine, and fewer paid tokens get processed. This does not magically solve compliance, but thoughtful architecture can reduce exposure and spending by design. Now let me show you the money, because people say save thousands with absolutely no calculator in sight. Here is a transparent example using the upper end of the project savings we have observed. Imagine a business processing 6,000 tasks each workday, 260 days yearly. Each cloud request averages 2,000 input tokens and 500 output tokens. That is substantial volume, but plausible for automation. At the published GPT 5.4 standard price used in my calculation, that cloud-only workload reaches $19,500 per year. On projects with 90% token savings, $1,950 remains. For a hardware proxy, add two 128GB Ryzen AI Max Plus 395 framework desktops. At the comparison price AMD cited, $5,132 total before electricity and operational overhead. Add roughly $100 of annual power. Hybrid first-year total, about $7,182. Cloud-only total, $19,500. And modeled first-year savings, $12,317. Yes, the title is real, but 90% happened on many of our projects, not every project. And this dollar calculation uses a hardware proxy rather than my receipt. Your workload determines your result. If you process 50 tasks daily, do not buy 2 machines because an excited woman on YouTube told you. Please, I am begging you, measure first. Quality comes from the system surrounding the local model. RouteLLM reported over 85% cost reduction on one benchmark while maintaining 95% of GPT-4 performance. FrugalGPT found savings from 50 to 98% across its tested datasets, sometimes improving accuracy. Different models make different mistakes. Most expensive never means correct on every task, and your business is not a public benchmark. Your documents, brand voice, support tickets, code bods, edge cases, and standards are the benchmark. Start by pulling usage, requests, tokens, retries, and high-volume workflows. Choose one repetitive job. Classification, extraction, summaries, or reformation are perfect. Then build a test set containing normal and ugly cases. Run the frontier model first to establish your quality baseline. Test a local model on examples using one-step instructions, shorter context, and an output schema. Ask it to be consistent, not brilliant. Create the gate. Missing fields, failed schemas, low confidence, situations, or policy risk must escalate. Then compare quality, speed, rework, and cost. After the numbers work, should you invest in hardware? The future is not one model swallowing every task. It is a portfolio. Local workers, frontier orchestration, deterministic checks, and humans. Ask which parts never needed premium intelligence. That question is worth thousands.